Good morning, students. This is 8th Science, chapter number 14, Light. Today we are going to cover the structure of the human eye, part 2. So, we'll start with the part that is optic nerves. So, today we are going to see what are optic nerves. So, optic nerves, they are the messengers. They carry the message from the retina. We know that image is formed on this retina. Now that image which is formed on the retina, that message is carried from the retina to the brain. Who is carrying that message, beta? Optic nerves. So your optic nerves, they are doing the work of messengers. They are carrying the message. Which message? The visual message. Right, they carry the visual message from the retina to the brain. Right, so what are they? They are a group of nerves. They are a group of nerves which begins from the brain से nerves आती हैं and it enters the eyeball. This is your eyeball. This hole is what? It is your eyeball. So the optic nerves, it enters the eyeballs from behind. So this is the back part. So from behind you can see that the optic nerves, the red color optic nerves, they are entering the eyeball from the behind and they are spread out like this. Can you see the red color nerves? They are the optic nerves. That is not one nerve, that is a group of nerves, right? That is a bundle of nerves. From where does they begin? They begin from the brain and it enters the eyeball from the back. Right, and it carries message. It carries the visual message from the retina to the brain. So brain तक message पहुंचाने का काम करती हैं your optic nerves. Right, children? Now, this optic nerves, when they carry message to the brain, what does the brain do? The image of the object here, for example, you are having a tree over here. So the image of the tree which is formed on your retina is inverted. Ulti image banti hai on your retina. And this inverted and real, and it is very small image. It is carried from retina to brain. Then the brain interprets it. Then the brain says, oh no, this is inverted. This has to be erect. Then what does the brain do? The brain makes it erect and then it sends it back. Right? And then this is the way how we sense the actual object. The image of the object which is formed on retina is inverted. It is very small. Now that image is carried by the optic nerves from retina to brain. Then the brain reads it, it interprets it, and then it makes it erect. And then the erect image is sensed by us. Right, children? So these are your optic nerves. Now let's move to the next topic, that is your ciliary muscles. So ciliary muscles, here you can see some black color, this part. So if you see carefully, children, these black color muscles, they are holding the lens. In our eye, we know we are having the lens, right? Your convex lens. That lens is holded by, उसको holder तो चाहिए ना कोई पकड़ के रखने के लिए. So who is going to do that work? So it is the ciliary muscles which holds the lens in its position. Now ciliary muscles does two work. First thing, it is going to hold the lens. Second thing, what it is going to do is it is going to control, or it is going to help the eye to see the near and far objects clearly. Kaise? By changing the focal length of the lens. Focal length of the lens. Very heavy words, right? No worry, we will do it in detail in the next topic, but just let me tell you that what does the ciliary muscles do? Ciliary muscles, they can contract, right? For example, just imagine you are having that smiley yellow color sponge ball in your between your two fingers, right? Now you are compressing it. So as you compress that smiley ball, you will see that the ball becomes thick. Ball thick ho jati hai, right? So same thing happens over here. The ciliary muscles, when it will contract, when it contracts, the lens becomes thick, right? Lens becomes thick. And when the lens becomes thick, the focal length of the lens, it becomes less. And focal length lens ho jati hai, which helps us to see, by this we are able to see the near objects clearly. ठीक है, पास के objects हमें clearly दिखते हैं. And when children, the ciliary muscles expand, सिलरी मसल जब एक्सपैंड करेंगी तो जो साइज ऑफ लेंस होगा व्हाट विल इट हैपन, वो भी स्ट्रेच हो जाएगा क्योंकि सिलरी मसल्स उसे खींच रही हैं, राइट, आउटसाइड. सो द लेंस विल बिकम थिन दिस टाइम, पतला हो जाएगा. एंड एज द लेंस बिकम्स थिन, द फोकल लेंथ ऑफ द लेंस इट increases. Focal length increases, which helps us to see the far objects clearly. So it is the ciliary muscles which controls the focal length of the lens by contracting and by expanding, so that we can see the near objects and the far objects clearly. So that is your ciliary muscles. So its function is to hold the lens at its position, number one. Second thing, to control the focal length of the lens by expanding or by contracting. The next is sclera. Here you can see sclera, right? So the sclera is the white portion which you can see in your eyes. If you see your eyes, you can see the white portion, and in that white portion, the liquid, watery liquid is filled. What does this sclera do? It is just protecting all the internal parts of the eye, right? So that white color, watery, which contains a watery fluid, is your sclera. Next is blind spot. So children, blind spot, as you can see here, that is the area, that is the spot, that is the region on retina. Retina पे एक area है from where the optic nerves are entering, right? From this area only the optic nerves are entering inside. So on this area, children, on this area, there are no rod cells, ROD rod. There are no cone cells. We know rod cells and cone cells. They are the cells. They are the light sensitive cells which are present on retina. But on this blind spot, there are no rod cells, no cone cells. And this is the area from where the optic nerves is going to enter the eyeball. So here no rod cells and cone cells. So if children, the image of any object, suppose the object is tree, suppose image of the object is formed on this blind spot, then children, the tree will not be visible to you, because if the image is formed on that part, but that part does not have any rod cells or cone cells, so you will not be able to see that object, and that is your blind spot. Okay, so children, these are the parts of the human eye. So this was about the structure of the eye. Now let's talk about the working. How does the human eye work? Now children, we know that light is going to enter from this part. Now the first area, the first part from which the light enters is your pupil, right? The light is going to enter through pupil. So the light enters through the pupil, and when the light enters through the pupil, we know that the image real, inverted, and highly diminished image is formed on the retina. And this image, right? This image is converted into the image that is formed. The image is converted into electrical signals. Image is converted into, children, electrical signals. Image किसमें convert होती है बेटा? Electrical signals. Who does that? On retina, rod cells and cone cells are present. So these rod cells and cone cells, they convert the image into electrical signals. Now these electrical signals are carried by the optic nerves to the brain. They are transmitted from the retina to the brain with the help of optic nerves. Now these signals are received by the brain and the image is made erect by the brain, and then the brain helps us to sense the object. Right, children? So please underline few things, and that is over here. Very important question, working of human eye. Underline it very carefully. So first thing, the light enters through pupil. So please underline the word pupil. What type of image is formed? Real, inverted, and very small, that is highly diminished. Now the rod cells and the cone cells which are present on the retina, what will they do? They will convert the image into electrical signals, and these signals are taken to the brain, and then the brain is going to re-invert it, वापस से उल्टा कर देगा, means सीधा हो जाएगा, and erect image is formed, and then it helps us to see the actual object. So this, children, this is the working of the eye. Now let's move to the next topic, and that is the persistence of vision. The persistence of vision. Persistence. Persistence means to remain, right? To retain. So suppose if I keep an object in front of you and then I quickly remove the object from your sight, from your in front, from your eye, then too the image of that object will remain on your retina for 1/16 of the second. 1 upon 16, you can just divide and you can see what part you are getting. 1 divided by 16. Okay, utne time tak the image still retains on the retina. The image still remains on the retina even after the object is removed. So that is called the persistence of vision. So even after the object is removed from your eye, in front of your eye, the image is retained. Image abhi bhi hai on the retina. For how long? Not for 5 to 10 minutes. It is for 1 upon 16th of a second. And this is called the persistence of vision. This is your persistence of vision. So this is, children, the ability of our eye that it can continue seeing the image for a very short time even after the object is removed. So children, let's underline the definition for persistence of vision, and which is over here. Persistence of vision is the ability of an eye to continue to see an image for a very short period of time even after the object is removed. Object is removed, but then too the image is still there on the retina, and this ability of eye is called persistence of vision. Right, children? Chalo. Next is accommodation. So accommodation is again, children, the ability of the eye. Okay, this is the ability of an eye. For example, when you use your cameras to click photograph, right, children? So you might have, if you're having the manual lens arrangement, na, In that, if you want to click the photo of a near object, what do? You just change the setting of the lens, right? You have to change the focus of the lens. And if you want to click the photograph of a very far object, then too you have to change the lens position. You have to do some manual settings in the lens, right? Changes in the lens. But in our human eye, if we want to see the near objects or far objects clearly, then our eye does the settings. The eye changes the focal length of the lens. And this power of eye to change the focal length of the eye lens to see near object or far object is known as the power of accommodation, right? So just now I explained you. Let us just underline, but I'll give you an example before that. That is, as I told you before, that take a that yellow smiley ball, right, and hold it in your hand. So when you are holding it in your hand, and suppose you are not compressing it, you are suppose stretching it, आप relax कर रहे हो. So similarly, our eye lens is holded by ciliary muscles. Now, when this ciliary muscles, they are relaxing, then what will happen? As the ball, we are relaxing. As the ball is relaxing, the focal length, the ball, if you are stretching the ball from the up, right, you are not compressing, you are stretching. So, the ball will become thin. Ball thin ho jayega, right? So, similarly here also, when the ciliary muscles relax, the thickness of our eye lens becomes less. Thickness becomes less means it becomes thin. And as it becomes thin, its focal length, here it is not given, but in 10th you will come to know that when the lens becomes thin, जब lens पतला हो जाता है, उसका जो focal length है बेटा, its focal length is going to increase. And as the focal length increases, we are able to see the far objects clearly. So this, children, you can write in the form of a flow chart. That is, let me help you. That is, you can write that ciliary muscles. I'm writing it for you. You can underline this part and you can make this आप यहाँ पे एक छोटा सा फ्लो चार्ट बना लें of 2 lines, and you can write in that part that ciliary muscles, I am writing CM for ciliary muscles. When the ciliary muscles relax, lens will become thin, पतला हो जाएगा, and when the lens becomes thin, the focal length increases. Focal length increases. So increases के लिए arrow चलेगा, increases. Ciliary muscles relax, lens becomes thin, focal length increases, which helps us to see the far objects clearly. Far objects clearly. Right, children? With this, you can just write your full answer. When the ciliary muscles relax, the eye lens becomes thin and its focal length increases, and so we are able to see the far objects clearly. Next, you can write when the ciliary muscles contract, what will happen? Lens will become thick, focal length decreases, and we are able to see the near objects clearly. Beta, please take a screenshot of this. You have to write this in your science book. Science book mein, wherever you find the space at the top on this page, you need to write this. So please take a screenshot of this. So when the ciliary muscles contract, the eye lens will become thick, the focal length will decrease and we are able to see the near objects clearly. So this ability of an eye to do this, that is to change the focal length of the lens so that it is able to see the objects clearly, is called accommodation. Is called accommodation. So please underline the line over here, and that is, please underline this line, children. Very, very important. The ability of the eye to alter means change, to alter the focal length of the lens, to change the focal length of the lens so that it can clearly see all objects within a certain range is called accommodation. Right? So with this, we are ending our session here. We'll continue in the next class, children.